Hey, today we're going to talk about AppLab, which is a new programming tool from code.org. The cool thing about AppLab is it lets you design and write code for your program visually. So I can design all of the user interface components in design mode here and drag all these buttons over to the left to design what my program is going to look like. And then I can switch over to code mode and use a visual block-based programming language to write my code. If you've ever used Snap or Scratch or another visual programming language, this type of syntax should look familiar. Now what's really cool about AppLab is it allows you to grow from there and click Show Text. And now I can switch to another mode where I can continue to edit my code using JavaScript syntax. So if I'm very comfortable at the beginning using block-based code to build my program, I can do that really easily. But maybe there's a certain point in my learning where I get really comfortable with text-based programming and I feel like the blocks are getting in my way and I want to move on from that. I can click Show Text and map all those blocks over to text-based code and continue learning JavaScript and can venture on to new programming languages like Java, Python, whatever I want to learn in the future. So we're not going to talk about that too much anymore. We're going to talk about how to actually build a program using AppLab. So what I'm going to do is start over at the very beginning in design mode, and we're going to build this application from scratch. But I wanted to give you a quick overview of what AppLab was and show you what the final product we're building looks like. So let's get started. When you first start AppLab, you're in code mode, where you can drag different code blocks over to the workspace in order to build your program and run it. Before we get started coding, I usually like to start with some kind of design so that I can see what my program is going to look like before I get coding, whether that's using a UI tool like Balsamiq Mockups or doing a sketch on a whiteboard like I've done behind me. So what I'm going to do is take this sketch that I've done on the whiteboard and build the user interface using AppLab's design mode. So I'm going to click design mode here, and this takes me to the design toolbox, where I can see a bunch of different widgets I can use to build my program. I can use buttons, labels, drop-downs, text inputs, images, and other useful widgets in order to build my user interface. So behind me you see my interface for building a simple drum machine. All I have is 4 different buttons and they're labeled with what each button does. The first button I want to press and play a kick drum. The second button I want to play a snare drum. The third button I want to click and play a hi-hat, and the fourth button I want to click and play some type of sample that I choose. So to do that over here in AppLab, I go to the design toolbox and I drag 4 different buttons over to the canvas. Now you can see the buttons are rectangular by default and they just have the text button, which doesn't really tell you a lot about what they do. Therefore, you can edit these properties over here on the right side when you select one of the UI components. So I'm going to click on the button on the far left here called button and give it a more meaningful name. So I'm going to map it to this kick drum button here and make it look the same. So I'm going to call this one kick and give it the text label kick and also make it square by setting its width and height equal to 60 pixels. So see, now it doesn't just say button, it says kick, and it's 60 by 60 square. You can see I gave it an ID and text. Text refers to the text that's actually displayed on the button, whereas the ID is a unique identifier that refers to this button. So later when I switch over to code mode, I'm going to need to be able to refer to this unique button. So I can specify when a button with ID of kick gets clicked, you need to play the sound that corresponds to a kick drum. I'm going to do the same thing with all the other buttons on the screen. So if I click this button, I can do the same thing and call it a snare and also make it 60 by 60 pixels. Same thing here, I can do hi-hat, 60 by 60 pixels. And finally, I have my sample, and I'll set it to the same height. And you'll see we can drag them all around and make them arranged however we want. This is my preference. And we have a nice little interface that matches the one on the board. So now in AppLab, I can click Run to run my program. And you see, nothing much is happening yet, right? That's because I've designed a user interface so far, but I haven't hooked up any code to it. I haven't hooked up any events, and I haven't referred to any of the IDs or anything like that. So that's why I need to go over into code mode to have things start happening. But so far, this is really good because we already have a user interface and can already visualize what our program is going to look like. So now all we got to do is hook up the different events and upload our sounds, and we'll be off and going. So AppLab automatically saved this project, but I'm going to go ahead and give it a meaningful name. Instead of Untitled Projects, I'm going to call it Drum Machine and click Save. And now when I come back later, I can come back and open this project. Let's switch over to code mode and make our buttons do something. Here you can see that I'm in design mode, so I'm going to click Code to switch over to code mode. You see my toolbox changes. Instead of the design toolbox, I can see different categories of blocks that I can use in my code. On the right side is the workspace where all of my lines of code go. These lines of code power what our user interface on the left will do. So, what do I want to happen? Well, for the kick drum, I want it to play a kick drum sound. So, the first thing I need to do is learn about events. Events are when something happens. So our code and our buttons, they listen for different events from the user. The user interacts with our program, whether by mouse click or some kind of keyboard button press. Our program cares about those events and wants to respond to those events by either showing something visually, presenting a new screen, and maybe it'll play a sound in this case. So to do this in AppLab, there is a block under UI controls called onEvent. If I drag this block over to the code workspace, you can see there are a number of different inputs expected from the onEvent block that refer to our user interface. So what this is saying is onEvent, and then it has a space for the ID. Now, if you remember in design mode, each of the blocks here, we assigned a unique identifier so that we can refer to them in code. So if I click this little drop down next to ID, you can see there's a listing of all the different IDs already defined. And fortunately, we gave all of the buttons unique names instead of just button 1, button 2, button 3. We gave them names like hi-hat, kick, sample, and snare, so that we can tell which ID is referring to which button. So I'm going to select the ID for the kick drum. And what event do I care about? I care about the click event. When I click the kick button, I want to play a sound associated with the kick drum. So I'm going to leave it at click, but also note that we can select this drop down and see a bunch of different other events, like when I hover over something, when I press a particular key, things like that. So I'm going to start with just a click. And what do I want to happen when the kick drum button is clicked? I want to play a sound. Well, there's already a block for that defined called play sound, so I can drag that block over to my code. Now I don't want it to always play the sound. See, AppLab will actually execute all of these lines in order, 1, 2, 3, 4, right? But what onEvent is, it's a block that wraps other blocks. So it only conditionally should run the block if a particular event happens. So what I want to do is take this play sound block and move it inside of the onEvent function block. So when the click happens on the kick drum, then we want to play the sound. Where I started off earlier, if I put play sound down here, it would always play the sound. I only want the sound to be played on a particular event. When the event happens, the function inside here executes, which will actually run the block of code, one or more blocks of code that are inside of this function. So I'm using the play sound block, and I can select from, I can put any URL that has a sound that I want to play, but I already have some sounds I want to play on my desktop. I use these instruments sometimes at home, so I want to select one of those. So if I click the drop down, you'll notice there's a choose option here. So I click the choose option, and this actually lets me upload a file. For sounds, AppLab accepts MP3 files. So what I want to do is select the MP3 files that I have on my desktop. I have a sounds directory, and it has a kick drum that I'm interested in, so I select that kick drum, and it actually uploads that file. I can also click choose next to that sound, and it will actually take the file that I just uploaded and associate that with the play sound block. So now I say on event, when I click the kick drum, it will actually play the sound that I just uploaded. Those become part of my asset library. So let's see if that actually worked. I'm going to click the run button over here to run my program. And now when I click the kick drum, you can see I have a kick drum sound that plays. So that's really cool. It only took 2 lines of code here, 2 blocks, the on event block and the play sound block, and I was able to link a file that I had on my desktop that corresponds to a kick drum and associate that with a click event on a particular button on the user interface we just made. So let's continue and hook up more sounds to the other buttons that we have on the screen. So I'm going to go back to, I'm going to click reset here, and I'm going to drag some additional on event blocks over. And instead of with the kick drum, I'm going to associate one with the snare drum. I'm going to associate one with the hi-hat, and I'm going to associate one with the sample. These are going to still be click events, so I can leave all these at their current defaults. And then I just need more play sound blocks. Okay. And then what I'm going to do is upload some additional assets. So upload file. I'm going to select a snare drum that I choose. I'm going to select a hi-hat. Choose that, and then finally I'm going to upload a sample and choose that. Now you can see all of our different buttons have on event click and can play different sounds. Let's run it again. Kick drum, snare drum, we have a hi-hat, and then we have our sample. Very cool. So now that we have our buttons providing us with some audio feedback, it might be nice to add a little bit of extra visual feedback also to let us know that the button was pressed. That way, if I decide to bind key presses to these buttons, I can have some kind of visual indicator that something's happening. So what I'm going to do is make these buttons turn blue and grow a little bit whenever I press them. So in the UI design earlier in design mode, you remember each of our buttons, I set them with a width and a height of 60 pixels. But what if I want to dynamically change the width and height of those buttons and make them look slightly different? You see that it has a current like light blue or teal background color here, but what if I want to change that when the code is running? Well, under UI controls, we have a lot of other options here besides playing a sound. One of the options you'll notice is the set size block. So what that does is allows you to set the size of a particular user interface component. So just like the play sound button, you need to set the ID that you're referring to. So this is the kick button. So I'm going to set size of the kick button. And since it's currently 60 by 60, I'm going to make it just a little bit bigger. So I'm going to add 5 pixels. So I have it 65 wide and 65 high. And if I put the set size block into the play sound block here, and then run my program, you'll see when I click it, it grows slightly. See that? I reset, I run the program, and it grows slightly. So other than making it grow slightly, I'm also going to change the color of the button to give a little bit more visual feedback. So there's also this set property block down here. So I'm going to use that, and I'm going to put this under set size here. And what set property does is it lets you specify the ID of your user interface element, and then you can set any property from design mode dynamically. So what I'm going to do here is scroll down and find the background color, and I want to set the background color for the kick element. And what do I want to set it to? Well, I want to type in a string here, so I'm going to use quotes. And instead of a number, I'm going to type in the color blue here. And so when I press it, it's supposed to set size and grow and set the background color to blue. So let's see if that worked. There you go. You see that the button grew slightly, and it also set the background color blue. So one thing you'll notice here is that now it's permanently blue, and it's permanently in the state where it's grown to 65 by 65 pixels. The other buttons aren't doing that, so how do I get it back to how it was before? I want it to have kind of a pulsating animation. So how do I animate something using AppLab? Well, under Control, we have this block called Set Timeout. And what that allows us to do is add some sort of delay and then a callback function that makes something else happen after that delay passes. So what I'm going to do here is drag this set timeout block in, and then what that does is it will call the function here and execute all of the code in this code block after a certain number of milliseconds pass. So by default it's at 1 second or 1,000 milliseconds, which is probably a little bit long, so I'm going to have the set timeout set at 100 milliseconds and see how this looks. So what do I want to do? I want to return the button to its original state. So I'll use set size and set property again. AppLab actually allows me to draw a box and copy and paste a couple of blocks of code, or you can just use UI controls again and find the set size block and the set property block and do the same thing. So we're setting the kick back to 60 by 60, and we're setting the background property, the background color property, back to how it was before, which is like a teal color, and I believe that will work. And so let's try this. After 100 milliseconds, it's going to set the size back. Let's reset, run the program. And you see that? We got this nice animated pulsating effect when we click the buttons. Cool? So we're going to want to have the same animation happening for all the different buttons. But before we do that, let's try, I want to make the key presses also make the same thing happen. So when I hit the number 1, I want the kick drum to play, number 2 the snare, number 3 the hi-hat, and number 4 the sample. So let's try some key press events. I'm going to click reset, and let's go back to on event here, drag another one, and so we're going to do screen actually. So we haven't talked about this yet. If you go to design view, you'll notice there's an element called screen up here. So your application can actually have several different screens. And when would that be useful? Well, let's say you're making like a game, like let's say Mario Brothers, right? And each time your character, and each time Mario hit the edge of the screen, you want to load a new level. So that's what's useful about screen. You can start a new screen here and give it like the underwater level or something like that, right? And then this has its own design mode, so you can put new elements and new objects on the new screen. Or in our beat program, maybe we want to have one screen that has all of our drums, and then one screen that has all of our synthesizers, and one that has all of our bass instruments, for instance. So it's good to know the screen item as well. This is an ID that refers to the entire canvas, the entire UI of the screen you're looking at here. So why that's important here on key presses, when I press a key, I don't want to have to be, the point of me pressing a key is I can press it anywhere on the screen, and it doesn't matter where the focus of the mouse is. if I press that key, if I press the 1, I want the kick drum to play. So I want to say when there's a key press anywhere on the screen as a whole, so key press, then I want a particular function to happen. Now, how do I tell which key was pressed? Well, you'll notice this function gets an input called the event, and the event has information about the event that happened. So in this case, the event object refers to a key press. And so if I don't know what the event looks like, or there's some complex object, right, and it's not obvious how it works, we actually have a console function here under variables. And since event is a variable that's currently holding information, it's an object, I can drag this console.log block over here, and I can log it to this debugger that's at the bottom of the screen and see what's actually happening when I press a key. So what I'm going to do here is instead of logging an event, instead of logging like a message, I'm going to log the event itself. And so I'll be able to see an indicator in this debug console of what does the event object actually look like, right? So I'm going to click run, and now I'm going to press a key. I'm going to press the number 1 and the number 2. And if you see at the bottom here, our debug console is actually logging the event object to the console. And you can kind of see what the format looks like. So you can see there's a key called the character code. You can tell if Control or Alt are pressed at the same time for like special shortcut keys. And if you scroll over to the right here, you can see the key 1 and 2. So it looks like there's an attribute on the event called key, and that stores the actual, like a plain text name of what key I press. So I press the numbers 1 and 2, and I have a key called 1 and 2. So I know I can check event.key to see if the event was the number 1 or the event is number 2. So I'm going to check for key number 1. Okay, so I already have this on event. I know when a key gets pressed. So how do I check for check whether the key is the number 1? I can go to the control section here, and this has if blocks, and these let code conditionally run. So I want to play the kick only if the key that was pressed was the number 1. So I'm going to put an if block in here, and I'm going to check if event.key is equal to 1. All the operators are found in the math section, the math category of AppLab. So you can see there's a double equal sign, which is the equality operator, and it tests whether 2 values are equal. So I can use this equality operator as the condition in my conditional. So if something equals something else, then I want to execute what's in this block. So what do I want to check? If event.key is equal to 1. And you can see it made a visual indicator that I was typing like a valid variable here. So you see it turned purple, and you should see event.key equal to 1 here, and we know that we typed the right thing. So what do we want to happen if event.key equals 1? Well, we want to do the same thing that we did earlier. We want to play the sound corresponding to the kick. So I can go back, and I can go to the play sound block, and in this drop down I can find the kick drum, and I can reset it, and let's run it and see if my key press now presses it. So I'm not clicking the mouse anymore, I'm just clicking the number 1, and you hear the sound, right? There's the kick drum playing. I'm pressing 1 on my keyboard, and it's playing. Now what's missing here? Well, you can see in our code, my on event here, it also, on my on event, when I click the mouse, when I click the button directly, the kick drum has the animation and plays the sound. When I click the number 1 here, when I press it on my keyboard, nothing's happening. We have all this extra code up here that runs when I click the mouse, but it doesn't happen when I click on the keyboard. So as you can imagine, it would be nice to actually combine all of this code here and reuse it down here on the keyboard event. So what are we going to do? We should refactor our code so that we have one set of code that's responsible for playing the sound, setting the animation, setting the size, and then running the set timeout function. That way we don't have to repeat it over and over again for the click on the kick, the click on the snare, the click on the hi-hat, the click on the sample, and then the key presses for each of those. We'd be repeating ourselves a lot. So let's try to refactor this and make the code common and not repeat ourselves. So how do you take several lines of code that are used in many different places throughout your program and combine them into a single named block that can be executed everywhere and defined in only one place? Well, that's called a function. There's a whole section in AppLab for functions that and it allows you to define functions with inputs, and also execute functions. So let's go ahead and create a new function. So what should we name our function? First, let's think about what that function is going to actually do. I went ahead and dragged a function block and another one up here to the top, and we're going to define what kind of functions we need. The first function we'll probably need is a play instrument function. So I can name this function play instrument by typing into the box and replacing my function. Now, calling the play instrument function is probably going to need an input. So I'm going to go ahead and use a different block here. This function block has an input that I can specify. And so I am going to name this function play instrument. And what input do I need in order to play the instrument? Well, I need the ID, or the name of the instrument that I actually need to play. So I'm going to call the input instrument. And what do I want to happen? Well, you see down here, we actually play the sound and do the animation for the instrument in order to play it. And the name of the instrument is kick. So what I'm going to do is take the stuff inside of this onEvent and start putting it into a common function called play instrument. That way it can be reused for the snare, the hi-hat, and the sample. So I'm going to do set size. I'm going to set property, and I'm going to play the sound. Now, let's see. So at the beginning, we're going to set the size of whatever it is. So what would be useful here, since I need the ID, the instrument here, this variable, this input, is actually going to refer to the ID of the element. So instead of selecting from this drop-down, I can actually use a variable here that represents the ID. So I'm just going to use instrument here. That way it can accept multiple inputs. So I'm going to set the size and the property of whatever ID is passed in to 65 by 65 and set the background to blue. These two lines here are common. No matter what ID is sent in, we're going to make the button grow and set the background to blue first. But what's going to be different in our function? The sound that's played. This is going to be conditional depending on what instrument was passed in as an input. So I'm going to use some controls here and conditionally play a different sound. So I'm going to use the if block here and say if. Then I'm going to use the equals. And I'm going to say if the instrument equals kick, I'm going to use this play sound to play the amber here. Then I can use this plus sign here to add an else. And I can keep adding additional conditions here. So I'm going to say if the instrument equals snare, then I can take the snare sound and put it here. I can add another if and say if the instrument equals the hi-hat, I can play the hi-hat, and then otherwise I will play the sample. So instrument equals kick, snare, hi-hat, otherwise play the sound for the sample. And I could explicitly check if the instrument equals sample also. Okay? So now I have two things that execute no matter what the instrument is, and then I have a sound that plays conditionally, depending on what input is sent in. Finally, what else do we have in our initial click handler? We have this set timeout function that does the animation. So I can move this stuff over, and I have the set timeout function, and regardless of what instrument is played, after the instrument plays, I'm going to call the set timeout function, and I am going to restore the element to its original state. So instead of kick, I'm going to use our variable instrument, and I'm going to set it back to its original state, which is 60 by 60, and set its background color back to teal. And so now we have this common place where everything that needs to happen to play an instrument is all defined right here. So I can get rid of a bunch of code at this point. Instead of copying and pasting the code that was in here over and over again, I can just make a function call for each of the clicks and have it call play instrument. So on kick click, we are going to go back to the functions section, and we're going to call the function. So this is the call block down here, and I'm going to call play instrument. And when the kick is clicked, I'm going to play instrument kick. So I'm passing in the ID of the button. When snare is clicked, we're going to do the same thing. So this can be commonly used here. Now all of this code will match and execute the same function and the same blocks of code. And that way, if the behavior of play instrument changes, it will happen to all four of the buttons simultaneously instead of having to change everything in multiple places. And that's that. So let's see if this works, if we have any errors. I'm going to click run again and reset it. And you can see now every button here does the same thing. And they're all executing the exact same code. I'm not going to click the sample here because it's a 20 or 30 second sample and I don't want to have to play all the way through. But be sure that since these three work, this fourth one does the same thing because it executes the exact same code. Okay? So next we want to make sure that all the keyboard presses do the exact same thing and execute the same code up here. So I'm going to scroll down to where I initially specified on event screen key press and call a function. Okay? So I'm going to give it a more meaningful name than screen1 since it'll make more sense to me. And I'm just going to call it drums. So I give it an ID of drums. So now I know I can select drums, and when a key press is pressed on the drum screen, then I'll fire an event. And what is that event going to be? Well, I'm going to store a variable. I'm going to store the key that's pressed in a variable. So I can go to variables here, and I can declare a variable with this var block here. And so I'm going to drag that in, and I'm going to call a variable key, and I'm going to set it equal to event.key. And this is nice because I can just use the variable key everywhere to refer to whatever key is pressed at any given time. Then I'm going to create another variable called instrument. I will drag another block, and I'm going to call my variable instrument. And I'm going to set it equal to the result of a function. So what I want to do is create a function called getInstrument that will map whatever key is pressed to the ID of the instrument that's being played. So I'm going to create a function here that accepts an input. I'm just going to put it right above the event here. We can move it around later if we want. So I'm calling it getInstrument, and then it's going to get the instrument corresponding to whatever key is pressed. So I'm going to use the input key here, and then I'm going to create some conditionals. So earlier we had some conditionals that check the value of the variable instrument. I'm going to do the same thing here. I'm going to get an if. I'm going to drag it into getInstrument here, and I'm going to say if the key is equal to 1, I'm going to go back to functions. And functions also has a return value. So basically, getInstrument gets called, and it returns a value to whatever calls the function. So here I have variable instrument equals, and I'm going to call the function. GetInstrument. And I'm going to pass in the key that came in. Key is press, key stores event.key, and I'm going to set the instrument equal to getInstrument with the input of key. GetInstrument gets the key, it checks if the key is equal to 1, and if the key is equal to 1, what do we want to map that to? I'm going to map that to the kick drum. And then I can do this again and again. So I can do one for, let's see, I can do one for the snare and the hi-hat and the sample. And then, if it's not any of those, then the key press is probably invalid, so we don't want to play anything. So in that case, I'm just going to return false. Return false, and that means, that's undefined. Or there's no key that maps to that particular instrument. So I'm going to check if key equals 2, and then key equals 3, key equals 4. Okay. And then same thing, I'm going to return values to map all these together. And this is a little bit of extra work, but it makes sure our code is really clean. And as the code evolves, if we add 100 instruments, then it's going to be really easy to add and map new ones. It's not that hard for 4, but as our program grows, we want to refactor it into functions that make everything simpler. So I'm going to return snare, I'm going to return hi-hat, and I'm going to return sample. Otherwise, I return false. Okay? So we'll go back to where we called the function. We set instrument equals to getInstrument.key. And then what are we going to do? We can get rid of all this stuff. And then we can say if what? If instrument, right? If it has some kind of true value or a value in it, then let's call play instrument. We already have play instrument defined. So I'm going to type the name of the function and call it play instrument. And which one? Instrument. Okay. I pressed a key. I found out which instrument that key corresponds to and stored it in instrument because it's returned from the function. And then if it returns a true value or some kind of string, then play instrument. If it returns false, there's nothing to do. So that's all error checked. And this calls the same exact code as all of our mouse click buttons up there. So we have mouse click events and keyboard presses all mapped to the same play instrument function. So let's see if that works. I'm doing mouse clicks and now I'm doing keyboard. Right? Really cool. And then now I can put it all together and just use the keyboard, and I can play my sample, and I can press 3. Cool. And then now we have a little machine, and we can continue to expand on it and continue to add new instruments and new buttons and make something really complex. So a cool thing that AppLab has, it has this ability to share and remix it. So now that I've done this part, I could click share, and I can copy this link, and I could share it with you, and you could see what that looks like. And a cool thing about this program is it's actually visible on the phone too. So if you email or tweet that link and open it on a phone, you can actually use the touchscreen on your phone to play these sounds and samples. The remix button is cool because you can be inspired by any AppLab program and remix it and make it your own. For instance, on this program, you might want to remix it. I'll still have my copy, but you can fork it and remix it and make it your own. Maybe you want to add a whole new screen for piano keys, Or maybe you want to add on and use some of these other components we have here that we didn't use. So maybe you want to add some visuals with the turtle section here and draw on the screen. Or you could explore variables more and use other components like, let's say, the list block. So let's say you want to add patterns. So you could have your program record different patterns of key presses and save those in different sequences, and maybe build something that could let you create your own song and bring in a verse, chorus, and a verse, and have all these different patterns come together in a more complex instrumental that has many different assets uploaded. So that's it. I hope you enjoyed this video. I'm going to share the link on the website, and you can copy this program or study the source code a little more, and maybe you'll remix it and make your own thing. Keep following this channel. I'm probably going to make some additional videos, maybe some on AppLab, but also some on Python programming, web development, JavaScript, databases, and other things that might be interesting to you. So keep following along. This is the first video of hopefully many. Thanks.